Exercise 4b looks at graphs of polynomials, and I think you'll all agree that anything that helps us to understand what the graph's going to look like is certainly beneficial. You know, in a way, I would like to have done this polynomials chapter much earlier because we've had to do a lot of graphing and talk about graphing, and I think now, well, eventually we're addressing these clues that we can pick up from observing, in particular, the algebraic parts of the polynomial. We're picking up clues about the actual graph. So we'll look at two things. We'll look at, or we'll be able to determine how the graph behaves as x approaches plus infinity. So, for example, this end of it or this end of it. And likewise here we'd be talking about this, and as x goes to negative infinity we're talking about this end. So we're going to look at that, and that's helpful. And the nature of x-intercepts. So we know that where it cuts the x-axis is called the x-intercepts, or the roots, and then nature. So yeah, we'll have a look at how the polynomial, in its algebraic form, what it can tell us about these x-intercepts. Okay, the first one. What is it about the polynomial that will help us to understand what the graph is going to do, ultimately at the positive infinity, x positive infinity, or negative infinity? Well, there's two things we have to observe, and one is the degree of the polynomial. So we've got odd degrees and even degree polynomials. If you have an odd degree, so that's the first thing, and this is the second thing, a is positive, so a is the value in front of the leading coefficient. If the leading coefficient is positive and the degree is odd, then the function will go off to plus infinity. So, and as it goes to negative infinity, x goes to negative infinity, it comes down to y is negative infinity. You've probably picked that up already, but like I said, it would have been nice if we'd done this much earlier. What about our polynomials that have an even degree? So, you know that, and again, their coefficient is also a positive. So, because it has an even degree, the biggest term will always be positive. An even degree, so x to the fourth, x to the sixth, they're even, and they will be the overriding term. The biggest degree, x to the fourth, will have the biggest impact. It'll have more impact than x cubed or x squared or x. So that's why we just look at the term with the greatest degree. And if it's even if x is negative, a negative number to an even power will be a positive. So its ends will always go to plus infinity. So it's got quite a different shape. We see it with a quadratic. And we know that if a is a negative, which we'll look at in a moment, that it goes in the opposite direction. Okay, so what we were looking at, odd degrees, a is positive and a is the leading coefficient. Even degrees and a is positive. So we can get a sense of what the graph should do. Whereas odd degree and a is a negative, the leading coefficient is a negative number, then the negative of the big positive number overrides it and sends it negative, whereas if a is a negative and we've got a negative number to an odd power, which is negative, and negative mean it'll go off positive. Hope that's making sense and you can follow. You might slow me down and work those out for yourself if you think that's confusing. With the quartic, if A is a negative, the number in front of the x term is a negative, then it just turns everything big into negative. The thing we do know is about every polynomial of an odd degree, because it does this bend and its ends go off in opposite directions, we know it has at least 1 0. It must cut the x-axis somewhere because its ends go off. So these are odd degrees. So it's this one and this one. Because its ends go off in opposite direction, then it must cut the axis. So it doesn't matter even if this is all happening down here, the fact that this will go off means it will create a 0 or a root somewhere. And likewise, if this is all happening here, again, this will go off and create a root somewhere or a 0. So that's just an interesting observation. If your polynomial has an odd degree, there will be at least 1 0. Okay, let's move on to the nature of the roots. So to get the roots, we will need to factorise. Now, if you end up with a root with a power, so let's say that our polynomial is written in factored form, and it might have some other factors as well. But let's just focus on this particular one, this particular factor, x minus 3 to the power 2. It's an even power. Then we get a double root occurring at 3. Now a double root means it comes and it just touches the x-axis rather than intersecting. That should be. So it comes down and it might touch, or it might do this. Now that is really helpful when we're graphing. If we get this situation, even power, or even if that's to the power 4, any even powered root will create a double root at the x value, and any odd power is a point of inflection, so it cuts through or it might come down this way. So, like I said, that's really helpful, and we get that just from observing the factored form of the polynomial, and of course registering whether that factored form has an even power or has an odd power. And then just some other observations about the graph. If we look at the polynomial, we've established that the polynomial has a degree n, then at most the absolute maximum number of zeros is n zeros. That doesn't mean it has to have n. It can have up to n. It can't have more than n zeros. So, for example, here you could hopefully see that this would have degree 3, because our highest power of our x would be a cubed. That means that it has 3 possible places it cuts the x-axis, and yes, it does. It cuts at -1, it cuts at 2, and it cuts at 3. Now, like I said, it doesn't mean it will always, every cubic will have 3. We know that's not the case. Not every cubic will have 3, because y equals x cubed does have degree 3, and it has 1 0. It cuts the x-axis at one place only. What we can observe is that it can't cut at any more than 3 places. To find them, you will need to factorise, and we'll do more on factorising bigger polynomials like this when we learn how to divide by a polynomial. So this one has a 0 at 0, at -2, +2, and at 3. So 1, 2, 3. It also has 4 zeros, and if you think about the degree of that polynomial, the highest power of the x would be 4. Did I say 3? It has 4 zeros, and the highest power would be 4. The degree would be 4. What can we see is going on here? In this polynomial, we can see a double root occurs at -2, and it cuts through the x-axis at +1. So it's got a double root. Now that is a term that you do need to be familiar with, double root. I've seen that in multiple choice questions. So double root means it just touches. And it's easy to see whether a double root exists if it is written in factored form. And we know that if factor is raised to an even power, and 2 is even, then a double root occurs. We know that if we want to find the y-intercept, we just put x equal to 0 into the polynomial. You've been doing that for a long time. For polynomials, the behaviour of the curve as x becomes very large is governed by the sign of the leading term. We've talked about that. So that's a positive, it's a cubic, so a large x value cubed is a large x value, so it goes off to +infinity. And a cubic will have its ends will go in opposite directions. A negative cubic would look like this. It's that for coming in this direction. A negative x value cubed is negative, but that negative and that negative send it positive, and that's why it's going off here positive. But when the x is a large positive number, x is a big positive number, that is positive, but the -10 sends it in a negative direction. The degree determines the shape of the ends. Yes, odd degree, the ends going in different directions. So odd degree going off in different directions, odd degree going off in different directions. Even degree, ends going off in the same direction. Double root at 2, just touching, cutting at -1, cutting right through, and cutting at +1. Multiple roots, yes, got another double root at -1, cutting at 2, cutting right through at 2. The degree and the sign of the leading term determine the direction of the ends. You can read through those. We've probably already talked about most of that. I'll draw up these sketches for you when I've finished the video, so you can come back and have a look at them. And you should be right to do 4B.